For the property and casualty insurance industry, Guidewire operates as the dominant central operating system. It manages billions of dollars in policies, claims, and billing. But this creates an immediate architectural problem. Thousands of different insurance carriers run on this exact same platform, and every single one of them requires vastly different workflows, rating structures, and approval chains to function. When traditional software developers enter this ecosystem, their first instinct is often to crack open the core source code to build bespoke features directly. That traditional customization approach is a trap. Altering the base Java code introduces massive technical debt. It locks the carrier into their current software version, making future enterprise upgrades dangerously complex, if not impossible. Long-term survival in the Guidewire ecosystem requires a shift in thinking. To protect the upgrade path, carriers must discard customization and move all business adaptation into a decoupled configuration layer. Guidewire's central thesis is configuration over customization. All business-specific adaptation happens outside the core source code. This is achieved through the tripartite configuration stack. It relies on three separate pillars: the data model, the UI layer, and the business logic layer. Modifying this platform means you never touch the center. You build up these three distinct layers in parallel to the base product. Whether you are working in PolicyCenter, ClaimCenter, or BillingCenter, each major module leverages those external configuration layers to execute its distinct operations. To architect solutions here, a developer has to master manipulating these external orbital layers. You shape the software's behavior without ever corrupting the core engine. The starting point for any of this work is the local development environment. The primary environment is Guidewire Studio. This is a dedicated integrated development environment, or IDE, built exclusively to manage these decoupled configuration layers safely. Inside Studio, the master blueprint for the entire application lives in a single file, config.xml. This file acts as the primary control panel. It defines critical environment variables, establishing database connections, setting regional locale preferences, and defining Apache log4j logging the parameters. Because config.xml controls the boot sequence and module loading, precision is mandatory. A single structural typo here will completely prevent the local server from starting. With the server running, configuration begins at the bedrock, the data model layer. Guidewire handles data through XML-based entities. For practical purposes, these entities function identically to tables in a relational database. This visualization shows how an entity file works. By defining properties and foreign keys within the XML, the system automatically compiles them downward to build the rigid database schema. There's a strict rule at this layer: do not modify base Guidewire entities to add new fields. Instead, use an extension. By creating a separate .etx file, you safely append new data fields, like region code, to existing structures without altering the base table layout. The secondary XML component of the data layer is the typelist. Typelists function as enumerated lists. They define specific static values, like payment methods or status codes, automatically standardizing drop-down options across the entire platform. The data model dictates exactly what information exists and how it connects, but that information is invisible until we build a structural blueprint to display it to the end user. That brings us upward to the UI layer. This is where users actually interact with the data model we just defined. Guidewire issues heavy, custom JavaScript frontends. Instead, it relies on its own highly structured native framework. Screens are rendered exclusively through page configuration format, or PCF files. Look at this split screen. PCF files act as XML blueprints. By typing specific tags like text input or detail view on the left, Guidewire generates the rendered, standardized enterprise widgets on the right. These PCF widgets don't exist in a vacuum. They are mapped directly back to the specific entities and extensions established in the data layer. Guidewire Studio maintains a real-time relationship between these XML tags and the front-end rendering, catching mapping errors instantly before deployment. This layer also controls access. Role-based permissions can be injected directly into the PCF, dynamically revealing or hiding widgets based on a user's authority level. PCF files allow for rapid, standardized interface building. However, a static interface remains inert without a logic engine to drive its behavior. The brain of the Guidewire application resides in the logic layer. This layer is powered by Gosu, Guidewire's proprietary, statically typed scripting language. Gosu shares a syntax similar to Java, but it is built with a highly specialized purpose, interacting natively and directly with Guidewire's specific business objects. Gosu drives UI rules. It evaluates the state of the data at runtime to immediately decide if fields hide, are marked as required, or are completely disabled. Beyond the interface, Gosu governs business rules. This chart illustrates a logic branch for premium calculations. Validation rules evaluate data to ensure integrity, triggering warnings. Meanwhile, pre-update rules run secondary checks on clean data right before committing it to the database. Because of its object-oriented nature, Gosu scripts can be organized into modular, reusable libraries within Guidewire Studio, keeping the logic clean and maintainable. Gosu is the critical link. It takes passive UI screens and data tables and transforms them into an active, decision-making enterprise engine. Instantaneous logic handles immediate decisions, but insurance requires macro-level orchestration. A claim intake or underwriting approval might take days or weeks to resolve. To automate these long-term sequences, Guidewire Studio provides the Workflow Editor, a dedicated visual design tool. Every workflow relies on 3 core components: states, representing the process stages; actions, the automated tasks executed; and transitions, conditions to move forward. Architects build these sequences visually via a drag-and-drop flowchart. Underneath, the system continuously compiles that visual layout into rigid, executable XML structures. Workflows act as the ultimate orchestration layer. They tie the data, UI, and logic stacks together to enforce business compliance across time. We return to the primary architectural tension: adapting a massive enterprise platform without creating fatal technical debt. Configuring Guidewire is the specific, disciplined act of building and stacking the data model, the PCF interface, and the Gosu logic engine. Watch how these elements combine. The XML schema, the PCF interface, and the Gosu logic compile to form a bespoke configuration block. This block integrates into the Guidewire ecosystem, running perfectly parallel to the locked core, but never physically touching the base code. Adhering to this strict modularity guarantees a frictionless path for future Guidewire version upgrades. Slipping back into old hard-coding habits immediately compromises the carrier's agility, locking them into outdated infrastructure that cannot easily be patched or improved. True expertise in Guidewire architecture is defined by the ability to enforce system integrity while meeting complex business requirements. Mastery of this platform relies on the precise, non-destructive interplay between these 3 configuration layers.